Simultaneous equations are all fun and good. It's really cool once you figure out how to solve them and the method behind it. But how can I apply this to a real world example? Let's start with that. So say for example, you were a property developer, or a property developer came to you as an architect that said, right, Mr. Darius, I've got a certain perimeter and a certain area restriction on a building that I'm building. I want you to find what is the optimal length and breadth that I can use for my new property development. Right, I've got a perimeter length of 18 meters. And he also says in the same breath that I've got an area restriction of 20 meters squared. Those units are irrelevant, but just to convey this for a real practical example. So, you know the formula for calculating the perimeter and calculating the area of a rectangular space. X times y gives you 20 meters squared, and 2 lengths plus 2 breadths will give you 18 meters for your overall perimeter as a architect. So now, what does this look similar to from our previous example? You've got 2 equations, you've got 2 unknowns, therefore you can solve it using simultaneous equations. So let's denote this as equation 1 and denote this as equation 2. The first step we should start with is making x the subject of the formula. So taking equation 1, we take x now and we want to make it the subject of the formula. So we have 2x equals 18 minus 2y. But on inspection of this equation, the highest common factor here is 2. So we could divide by 2 if we wanted to. Let's do that because it'll probably make our working out easier later on. So you could have x equals 18 divided by 2 gives you 9 minus y. So this technically gives us a form of equation 3. Now, how can we eliminate x so that we could solve just in terms of y? Well, we would want to substitute equation 3 into equation 2. So let's do that. What's the first step now to do? Is to say, therefore, substituting three into 2. So whenever you see x in equation 2, you're going to substitute in 9 minus y. So you've got 9 minus y multiplied by y equals 20. Expanding this out further, multiplying y in, you've got y, 9y minus y squared equals 20. You can carry on with the working out up further. Over here, building on from this result, you have minus y squared plus 9y minus 20 equals 0. Because you can see this is beginning to look like a quadratic expression, so you would want it to be in its standard form. And if we had to multiply everything through by minus 1, because ideally you would just want your y squared term to be a positive. So multiplying everything through here by minus 1, you would have it in the form of y squared minus 9y plus 20 equals 0. And is it possible to factorize this? Well, you've got y, and what's the possible factors you could use to get 20? You've got 2 and 10, 20 and 1, 5 and 4. Well, if you know that your middle term needs to be, the resultant needs to be 9, 5 and 4 is quite the obvious answer. So you've got 5, you've got 4, You know that your C term needs to be positive, so both the signs need to be the same. And you've got a negative term for your B, so you've got minus and minus. Therefore, y must be equal to 5, or y must be equal to 4. So now you've got your two possible solutions. And same like the previous example, you solve for y. Now you would want to substitute back these two results into equation 3. Substituting our first result or solution of y equal to 5, we would have x equals 9 minus 5, which would be equal x equals 4. That would be our first result, and y must be equal to 5. Taking our second solution of y equal to 4, we'd have x equals 9 minus 4, that must be equal to 5. Or let's draw it over here. X must therefore be equal to 5. And y must be equal to 4. And there's our possible solutions. Two solutions that we would want. So now that you've got these two solutions, you can now go back to your property developer as an architect and say, right, Mr. Boss Man, you gave me two restrictions on the area and the perimeter of this building area that we had. And the possible solutions for x and for y that would still give you the best perimeter and the best area given the restrictions would be x equal to 4 and y equal to 5, or x equal to 5 and y equal to 4. And that would be a real world application of you trying to solve a simultaneous equation. So if you're still here and you're watching this video, I'm pretty sure that you really want to consume more and more and more knowledge. And you needed a fun fact for today. So fun fact today on simultaneous equations, although you might not see it now, further down the line, especially when you start getting to fundamental engineering mathematics or basic chemistry and you need to start balancing massive equations in university, understanding linear algebra and the way that it behaves and simultaneous equations is the bread and butter of maths at university and also when you start your professional career. So you might get equations in the form of something in terms of x, y, and z, and you might be doing something that might be Gauss reduction in matrices, which is a big form of simplification in mathematics, but these can also be solved in terms of simultaneous equations and the same methods that I taught you in this lesson. So there are quicker, faster methods that do exist, like Gauss reduction in matrices, but the fundamental simultaneous equations that you learned today, the same method can be applied to them. So further down the line, you could be using those methods, but for now, really understand these simultaneous equations methods I taught you today. Thanks for joining. I hope you liked it. I'll see you later.